Hello everybody, welcome back. Today we're doing example 2 from section 7.5, continue with the elimination strategy to solve a system of linear equations. So if you look at this example here, some would look at it and say, okay, this is a nightmare. It's not a nightmare, but it is a little more difficult. We have fractional exponents this time. So what we're going to do is we'll name our two equations, equation 1, equation 2, so you know what I'm talking about when I'm referring to the equations. So first thing I would do is get rid of the fractions. And we did that in a previous example. So I would multiply this by the least common multiple, which would be the same thing as common denominator. So the denominators here are 3 and 2. So if we multiply this whole thing by 6, it'll eliminate those fractional coefficients. So the first one we're going to do is we're going to multiply equation 1 by 6. Okay? We're going to multiply equation 1 by 6. Alright? So when we do that, we take our equation, multiply it by 6. So everything has to be multiplied by 6, right? First term, the second term, which is the y term, and the constant at the end. Okay? So everything multiplies by 6. Alright? Oh, that's a 4. Obviously that should be a 6. Got that. Alright? So in doing so, we'll clean that up in a minute. And the next thing we want to do is we want to multiply equation 2. There we go. Multiply equation 2. Well, this one here, you can see there's a 2, a 4, and a 2, so obviously the LCM is 4, so we're going to multiply this whole equation by 4. Okay? Multiply this by 4, this by 4, and it doesn't matter if you do the front or the back, it doesn't make a difference, right? Okay? Alright, so let's clean this up. So we'll take this equation 1 down and we're going to clean it up a bit. So we're multiplying this by 2. We get 6 times 2 is 12, divided by 3 is 4x. Okay? Subtract, because obviously we have the subtraction sign, and then 6 times 1 is 6, divided by 2 is 3, so we end up 3y, and 4 times 6 is 24. So this equation right here, first equation, is equivalent to this, much cleaner. Okay, so there's our new equation 1. It's equivalent, still equal to the first equation, but we've manipulated it so it'll help us moving forward. Okay. Next equation, let's do the same. 4 times 1 is 4, divided by 2 is 2, so we end up with 2x. Let's do this for a second. We end up with 2x plus, and then it's 4 times 1 divided by 4, so it's obviously just y. Okay. And then 4 times 5 is 20 divided by 2 would be 10. Okay. And there's our second equation. So you'll notice again that the coefficients aren't the same. So the first equation, what we're going to do is we'll leave alone. Leave equation 1 alone. Okay? We're going to leave that one alone. And the second equation, we're going to multiply by 2. Multiply by 2. And the reason we'll multiply by 2, then we'll have that x as a 4, and then we're going to be all set. Okay? So if we multiply everything here by 2, 2 times 2 is 4, 2 times y is 2y, and that will give us 20. And it is set up perfect now for elimination. Okay? So now we're going to subtract the two equations. Alright? So I usually underline the second equation. Alright? and then we're going to hit subtract in brackets, right? The whole thing is going to be subtracted. Each term will be subtracted. Okay? Right? So our new, we end up with 4x, subtract 4x, that's gone. Negative 3y, subtract 2y, so we end up with negative 5y. And 24, subtract 20, and that gives us, ends up with, we end up with 4. Okay? We end up with 4. And then we divide both sides by negative 5. Alright, so divide by negative 5. That's gone. Divide that by negative 5. And we end up with y equals. That's a terminating decimal, so I'm okay with that being a decimal. Negative 0.8. Okay? Or you can leave it as negative 4/5, whatever you prefer. It doesn't make a difference. Okay? Once you have your y value or your x value, then we're going to substitute that back into either one of the original equations. It doesn't make a difference which one. Okay? So I'll substitute to equation 2 again. It's not going to make a difference. So I got my equation, and everywhere I see my y value, I'm going to put in negative 4/5, or you could put, it's like I said, it doesn't make a difference. Alright, I like to deal with fractions, so we're going to do some fraction work here. Again, you can use the decimal if you want. I like the fraction work, personally. Negative 4/5, right? Okay. So everywhere we see y, we put in negative 4/5. So let's clean this up a bit. So the negative 4s are actually going to divide, so you end up with negative 4, so you end up with negative 1/5, right? Oh, not plus or minus, it's negative 1/5, because the 4's divide out here. Negative 4, 4 divided by 4 leaves you with the negative 1/5, okay? And now you can multiply this whole thing by 10, just to get rid of the fractions. That's what I would do. Multiply everything by 10, right? Every term by 10. Multiply every term by 10. Okay? This will really clean this up for you. So 10 times 1 divided by 2 is 5x. 10 times 1 divided by 2 is 2. And 10 times 5 divided by 2 is 50. Divided by 2 is 25. Right? We add 2 to both sides, so that's gone. Add the 2. That gives you 27. Right? And then divide both sides by 5. You end up with 27 divided by 5, or 5.2. Okay? So your solution is, as a fraction. The fractional solution, which I don't mind, is 27 over 5, comma, negative 4 over 5, right? Or, because it's terminating decimals, you can leave it as a decimal answer of 5.2. Or 5.4, sorry. 5.4, don't mind me. 5.4, that'd be 20, that's 26. 5.4 and negative 0.8. Oh, I don't know where the 1 came from, my bad. So both these are equivalent. Now you want to do a quick verification. Let's show you the Desmos program that you know I do enjoy. So we take this, okay, and we're going to confirm that. So the Desmos program, we open up our Desmos, right? We put the original equations in, which was 2/3 x minus 1/2 y equals 4. This is why I like the Desmos, so smooth. 1/2 x plus 1/4 y equal to 5/2. There's your intersection point, and it is indeed, let me just show you. Alright, I got over there, sorry, so you can see the equations. 5.4 and negative 0.8, which was our solution. Quick verification. So to verify your solution algebraically, what you want to do is, and I'll do it with the decimals this time. Like I said, it doesn't make a difference. Take one of the equations. So I use the second equation here. So I'm going to use the first equation to verify, because I used the second equation to solve for my x variable before. So my x variable is, I'm going to use fractions. You know me, I like fractions. So I'm going to use the 27/5 for x, the y value, negative 4/5, right? So we plug that into the original. I lost that last equation. It's no big deal. I'll put it back here now. So the original equation is where I'm getting these values, right? So there's the original equation. There's x, there's y. I substitute it in. All right. So that's going to give me 54/15. 2 times 27 is 54. 3 times 5 is 15. So I end up with 54 divided by 15. And negative times a negative, I end up with a positive. So it's positive 4/10. So plus 4/10. All right. And obviously you need a common denominator here. So common denominator would be 30, right? So that would be 108/30. So I got to double it. And that would be 12/30, because I got a triple numerator and denominator. And then I add these together and I get 120/30, which you guys know, you guessed it, is equal to 4. So 4 is equal to 4. There's your verification. One thing I love about algebra, you'll hear me say it a few times, you can't get these wrong, and what I mean by that is you can verify your solution a number of different ways, okay? Just to make sure you got this, all right? All right, and there is your solution. I'm just bringing this up to fix this, my apologies. Okay, so your solution is right there, and you could use the decimals to check it as well. You check your understanding, same idea. There's your answers for that. We kind of ran out of time, so I'll do example 3 in the next video. I hope everybody enjoyed the video, and if you have any questions at all, please ask. Thank you very much. We'll talk again soon when we try example 3. Thank you.